Hi guys, this is vectors and we're doing some proofs in this video. This is the final video on vectors, so if you haven't seen the previous two, definitely give them a look because we will be referring to some of the stuff I've said and talked about previously. If you have watched those, in this video we're going to concentrate on how we prove lines are parallel and also that points are on a straight line. So that's the purpose of this video and our common high-level questions in exams. So let's get started. If we look at this vector here, A, so this is referring back to our first video that we did or talked about, where we have A, and then 4A is just 4 times bigger. Now, these two lines are parallel, okay, because this one is just 4 times bigger than this one. And that's what we're going to aim to do when proving lines are parallel. We're basically going to try and prove if they are or have a scale factor of each other. So we say that vector A and KA are parallel if we have A and it's just got a scale factor K, where K is just a number or a fraction or something. So that's what we're going to do. We're going to try and prove lines are parallel by showing that they have a scale factor and therefore must be parallel. Later on, when we have a look at straight lines and trying to prove a straight line, we'll do exactly the same thing. We'll prove the two lines are parallel, and then if they share a point, it must be a straight line. So think about it. If I've got a parallel line here, at the minute they're not a straight line, but if this point here is the same as this point here, and they're parallel, they must be a straight line. And we'll go into a bit more detail of that in the examples towards the end. For now though, let's just prove that some lines are parallel. So here's my first example. D is the midpoint of AC, so here is AC and D is the midpoint. E is the midpoint of AB, so there's E and there's the midpoint there. So this is based on what we were talked about in the second video. We're told that DA, so D to A here is A with the arrow going between D and A, so that bit's already been done for us. That's fine, that's good. If not, we would have put that on with the arrow. And E to A going from here to here is little b, and again E to A, so the arrow's in again. That's been done for us. If it hadn't been, we would add that on with the arrow. Now, because D is the midpoint and we know that D to A is A, what we could also do now is just say, well, that must be A as well, from C to D. Likewise with B to E, if E is the midpoint, that must be B. So we can just add that on now as a little bit of an extra. Prove that D to E, so this line here, D to E, is parallel to CB, which is the bottom line here. So to do that, we need to work out what DE is, we need to work out what CB is, and then see if we can factorise it to prove that they've got a scale factor. So let's do that. Let's start off with CB, I suppose, because that might be the easiest. So CB here. So let's work that out. So I'm starting off at C, so I'm going to go that way around, because obviously I don't know what that is, just going to follow the journey there. So A plus A, or the whole thing, is 2A. And I'm going against the B's here, so remember when you go against the flow, you just put a minus there, or if it's already a minus you put a plus, basically you change the sign. So minus B, so that's minus 2B in total. And then if you factorise that, you take a 2 out, you have 2 and in brackets A minus B. So that's what we're aiming for, this A minus B. If we get that, they're parallel. So quite simply, we've worked out that one. Now let's work out DE. You could have done this one first, it doesn't matter. So D to E, I'm going to go that way, which is A. And then going against that one, which is B, so minus B, and then that's it. And as you can see, straight away, A minus B, and then this vector here, CB, is just twice as big as that. So I've proven that they've got a scale factor. This one is just twice as big as this one, and therefore, they're parallel. These 3 dots here just mean therefore. Of course, you can write therefore if you wish. So therefore, parallel, because they have a scale factor. You can go in a bit more detail if you want with that, but essentially because that's just twice as big, they're parallel. Okay, let's have a look at another one then. The diagram has vectors A to D, so A to D, and that's 3a minus b. So I'll put that on now. And CB, which is this one here, and that's 2a plus 4b, okay. D is the midpoint of AC, so again I can just put that there, because D is the midpoint, so I've got, that's going to be the same, so that's fine. And E is the midpoint of AB, but I don't know what AB is yet, so I can't do nothing with that. Are DE and CB parallel? So we're looking at that parallel again. Now, I need to obviously work out DE, and I need to work out CB. CB is easy, I've already told what it is, I now need to work out what DE is. So if I start at D, I can go that way, I know what that is, but I don't know what that is, so I'm stuck. Let's go the other way. I could go this way, but again, I don't know what that is. So I have to find out the whole length of A and B, and then because that's the midpoint, I can then just half it. So that's my first step in answering this question. I need to work out AB. So AB, I'm going to go down here and then across here. So I'm going to have 3a minus b plus 3a minus b plus 2a plus 4b, and then I'm just going to simplify that up. 3a is 6a, plus 2a is 8a, minus b is minus 2b, plus 4b is plus 2b. And I'm going to factorise 2 out of that. Oh no, I didn't do that yet, do I? Sorry, that's just the whole thing. Yep, so I'm getting ahead of myself. So AB is 8a plus 2b. So half of that, because this is the midpoint, would be 4a plus b. And of course, this would also be 4a plus b. And it is going that direction because that was AB. So they're in that direction there. Okay, so now we've worked everything out. We can now work out what DE is. Okay, so DE, I'm going to go that way, which is going against that, so that's going to be minus 3a, and then change the sign there, so that's plus b, and then that is going in the right direction, so plus 4a plus b, which leaves me with minus 3a plus 4a is a, and then plus b is 2b. So that's what DE is. If I look at this, I just need to factorise the CB. So if I factorise that, take a 2 out, I'm then left with A plus 2B, which as you can see is the same as DE. So again, this one is just twice as big as this one. It's just a little harder because I had to work out AB first. Okay, so that's the basics of it. And there's the first 2 examples. Let's have a look at some straight lines then. So essentially it's the same concept. We still prove that 2 lines are parallel, but we just also show that they've got the same point. So let's have a look at this example here. E is the midpoint on AB. Sorry, I've got used to it, haven't I? Midpoint. E is the point on AB such that A to E and E to B is in the ratio of 6 to 1. So there's that ratio again. So I'm going to come up here and just do a very mini table. 6 to 1 with my total, which is 7. So the fraction of A to E, so A to E would be 6/7, so that's going to be quite big. And then the fraction of E to B, so this is obviously going to be the E, so A to E and E to B is going to be 1/7. Now, I know the whole thing is 7a already. So if the whole thing is 7a, what's 1/7 of 7a? Well, that's easy, that's a. And what's 6/7 of 7a? Well, that's going to be 6a, because then it's 6a plus a is your 7a. So that's the first bit dealt with, happy days. M is the midpoint of BC, so there's BC. I don't know what it is yet, so I can't do nothing with that, but I do know that M is the midpoint. D is the point such that A to C and A to D is 5 to 6. Now this has made me a bit careful, and this tripped me up when I first saw a similar question, is I was doing it with the ratio here, but look at the difference. A to E and then E to B, so that bit to that bit. This one, sorry, is A to C, so this bit, and then A to D, so it's the whole thing. So you have to be really, really, really careful and spot whether it's that bit and that bit, or whether it's that bit and then the whole thing. In this one, it's this bit to this bit. So we know that AC, and we've got AD, and then we've got 5, and we've got 6. Now the total, we can't use the total at the minute, because the total is the whole thing, which is AD. So you could in fact say that that's the total. But they're not going to make this too tricky. We know that A to C is 5B. Okay, we're told it here. A to C is 5B. So how do you go from 5 to 5B? Well, we times by B. So do the same thing here, times by B, which means that A to D, the whole thing, is 6B. So if that's 5B and the whole thing is 6B, that must mean that this is just B. So that's a real tricky one to spot differently to this. And you just have to be very, very careful and just make sure you look at your points and see what you're dealing with. But that's how you can get that length there. Okay, let's have a look what we're doing then. Prove that E, this one here, M, this one here, and D are all on a same straight line. Now, I don't think I've actually done this on a straight line, but it doesn't matter. I ain't far off, we'll draw it anyway. There we go. Okay, so that's what we're trying to do. We're trying to prove that that's a straight line. So the first thing we're going to do is we're going to work out E to M. Then we're going to work out M to D. We're going to prove that they're parallel. And then because M is a point that's on both of those lines, it must be a straight line. So that's our plan of attack. Let's get going. So E to M, I can go this way and then this way, but I don't know what that is. Or I can go this way, and this way, but again, I don't know what that is. So I need to work out what BC is before I do anything. So BC, so I'm going to go this way, which is minus 7a, because I'm going against the flow. So minus 7a plus 5b. Oh, that's it. Done. That was easy. Okay. So B to C is that. Now M, we were told, is the midpoint. So if I half this, it's going to tell me this bit, and half it, it's going to tell me this bit. But we did B to C, so our arrows are that way. And I'm going to half it, so minus 7 over 2A plus 5 over 2B. And the same thing for this, minus 7 over 2A plus 5 over 2B. Sorry that's a bit small. Hopefully me talking about it, you can do it yourself if that's what you're doing. So let's go back to E to M. We should now be able to do that. So that's going to be A, because that's going in that direction, so that's fine. And then down here we have minus 7 over 2A plus 5 over 2B. And then if you simplify that, basically that's minus 3.5. So add, A, take away 3.5 leaves you with minus 2.5, which is minus 5 over 2. Of course, you can do the fraction of it, but sometimes it's easier just to do what I just did in my head. And then I've got my plus 5 over 2b like so. What can we do now? Well, I'm going to factorise minus 5 over 2. Now, what some people do is they'll factorise 5 over 2 out and leave you with minus a plus b, and that's absolutely fine. I don't like doing that, so I'm going to factorise out minus 5 over 2, which will leave me with a and then minus b in there. And you can check when you've done that to expand it. Minus 5 over 2 times a is minus 5 over 2a. Minus 5 over 2 times minus b. Minus times minus is a positive. It just makes this nicer. It's personal preference. You could have just done 5 over 2 out. That would have been absolutely fine. So I've done my E to M. Now I need to do my M to D. So I'm going to go down here, which is minus 7 over 2a plus 5 over 2b, and then plus that b there. So that's going to be minus 7 over 2a, and then b plus 5 over 2b is just going to give me 7 over 2b. And again, I'm just going to factorise out minus 7 over 2, because then that'll leave me with a minus b inside there. And again, I have proven that they are scale factors. A minus b, and they've just got different scale factors. So that proves they're parallel. And because they both have m, the point m, so this bit's parallel, because they have the same point. As I said, you've got a parallel line here. If they have the same point, they must be a straight line. So on the exam, just write something like EM and MD are parallel and have M to be the same point, therefore it must be a straight line. I'm not going to write that like that because it's going to extend the video, but that's what you need to write on your exam paper. Okay, so I've got one more for you, very similar context there, but just ever so slightly different, which is here. Okay, so M is the midpoint of AC. We don't know what AC is, so I can't do nothing. And E is the point here such that it's 3 over 2 of BM. The point D is an extension of the line BC, such that BC to CD is in the ratio of 1 to 2. So again, let's just look at that from the previous example. B to C, C to D, that's fine. It's just a normal ratio. It's not BC and B to D. It's just that bit to that bit. So I can just draw my little table. Well, I might as well just do it here. So I've got BC, CD, 1 to 2, total of 3. So this bit here, BC is just 1/3. And we know that that equals B, we're told that. And this equals 2/3. If 1/3 is B, 2/3 must be 2B. Likewise, if you know that's B, just like we did before, you could put that on the table and say, well, okay, how do I go from 1 to B? Well, I times by B, so times by B here as well. And then you'll have 2B. But either way, C to D is 2B. So that was easy. And we need to prove that A, E to D is a straight line. And that isn't going to quite work. So just imagine that that is a straight line. Okay. Diagram not drawn to scale, which I'm sure the examiners will also have on their paper. So what do we need to do? We need to work out A to E. We need to work out E to D, prove they're parallel, and because E is the same point, must be a straight line. So that's what we're going to do. Let's get cracking. A to E, I need to know that, and I need to know that. I don't know that. The only way I can get that is to work out A to C first. So first step, A to C, which is minus A plus B. That's the midpoint. So it's going to, A to M is going to be half of this. So half of minus A plus B. Or you could just go straight ahead and expand it and say that's minus a half A plus a half B. It's entirely up to you how you prefer. Probably expanding it's better. And so I now know that bit, but I don't know this bit here, the M to E. I don't know that. So I should put my arrows on, A to C. But we're told that B to E, the whole thing, is 3 over 2 times B to M. So if I now work out B to M, I can times it by 3 over 2 to work out the whole thing. So let's do that then. So B to M. So here's B. I'm going to go up that way and down that way just because it's with the flow, which is A plus, I'm going to expand that straight away and say that's minus a half A plus a half B. So A plus minus a half, or minus a half plus A, leaves me with positive half A plus a half B. So B to M is half A plus half B. I'm going to factorise a half out straight away. So I now know that this bit here is a half A plus B. We're told that BE, the whole thing, is 3 over 2 times this. So all I'm going to do to work out BE is 3 over 2 times by BM. Well, BM was this, which is a half A plus B. So just multiplying fractions here. So times the top times the bottom. 3 times 1 is 3. 2 times 2 is 4. So it's 3/4 A plus B. Why does that help us? Well, if this is half AB and the whole thing is 3/4 AB, it means that M to E must be a quarter A plus B, because a half plus a quarter gives me 3/4. So I think I'm in business now, because I can work out A to E, and I've got everything I need to do to work out E to D. Yeah, so let's do that. So A to E is this one here. Again, I'm going to expand the bracket straight away, which is minus a half A plus a half B, going up here, plus, I'm going to expand the bracket again, which is a quarter A plus a quarter B. And then I'm going to simplify this, so minus a half plus a quarter is minus a quarter A, and then a half B plus a quarter B is 3/4 B, and then I'll factorise out minus a quarter, which will leave me with A minus 3B. Cool. So that's that first bit done. And now I need to work out E to D. So going this way, I'm going against the flow here. Remember, I did B to E, which is that way, so I'm going against that. So I need to do minus a quarter. I'm going to expand the bracket again. So minus a quarter A minus a quarter B. So I've gone that way. Then I'm flowing with it, so that's fine. That's minus a half A plus a half B. And then this bit here, which is just 2B, so plus 2B. Don't fractions make this a little bit more entertaining? Okay, let's look at the A's then. So minus a quarter, minus a half is minus 3/4. And then I've got minus a quarter B plus half B, which is a quarter plus a quarter B, plus 2, which will give me 9 over 2B. Sorry, 9 over 4B. Sorry, 9 over 4B. So I'm just going to go through that again, just to double check my own working. So minus a quarter B plus a half B is a quarter B plus 2, so it's 2 1/4 B, which is the equivalent of 9 over 4. Yep, that's fine. Then I'm going to factor out minus 3/4 from that, which leaves me with A minus 3B. And as you can see again, I have the same vector there, just different scale factors, which prove it's parallel. I might as well write this out to finish it off. So both scale factors of A minus 3B. Okay, so both have the scale factors of that vector there. So both scale factors of the A minus 3B, and have E as a common point. Therefore, A, E, and D are points on a straight line. Okay, so because they both have scale factors of A and B, I should probably put a bit here, shows they're parallel, and they have E as a common point, it proves that it is a straight line. So they're the most common types of questions, guys, when you have to prove something, whether it be prove they're parallel or prove it's a straight line. It does come up more often than not when dealing with vectors, especially the higher level questions. So hopefully that helps. Thanks for watching.